Hello learners, welcome to this tutorial on Arduino Mega board programming and simulation. So in this video tutorial, I am going to discuss about on how to interface a 16x2 LCD with Arduino Mega board and also how to program this 16x2 LCD using the Arduino Mega board. So 16x2 represents, we have two rows. In each row we can display 16 characters on it. And these LCDs are used to display numbers, characters as well as graphics. So if we look at the pin details of this 16x2 LCD, it is having 16 pins. So out of the 16 pins, we have two power supply lines, VCC and ground. And there is one more line which is used for controlling the contrast of your display. So this contrast line, usually it is connected to a potentiometer. So by varying the potentiometer, we can adjust the contrast of your device. Then I have three lines, RS, RW bar and enable, which are control lines. D0 to D7 is your data line. Then I have a backlight power supply. Backlight plus and backlight minus. So this backlight of your LCD comes in different colors like yellow, blue, green, white. So we can choose a type of LCD for our application. So when a CPU wants to send some data to a LCD, it will send the data through this D0 to D7. So the information transferred from the CPU to the LCD can be a command or it can be a data. So how this data transferred from CPU D0 to D7 will be recognized as a command or a data. So if RS stands for register select. So we have two registers in the LCD, which is command register and a data register. So both the registers are 8-bit registers. So the data coming from D0 to D7, either it will go to a command register or it will go to a data register. It depends upon the voltage at RS line. So if RS is equal to 0, then D0 to D7 will go to your command register. If RS is equal to 1, then D0 to D7 will go to your data register. So this RS determines whether the information coming from the CPU is a command or a data. What is command? Command is nothing but we need to specify certain initialization part before sending a data. Something like whether I want to display my character on the first row or on the second row. If it is on the first row, in which position we have to display our character. So whether I want my character to move towards left or right, or whether I want a cursor or not, or whether the cursor should be in a blinking state or not, whether I should clear a LCD or not. So those information are treated as commands, and these commands are also given in the form of a hexadecimal code. So that is represented here. Here we specify different hexadecimal codes, and for each hexadecimal codes we have different functionality. Same way the data which we need to put it onto our LCD, something like at Mega 2560 programming. So such information also will be represented in terms of a ASCII values. Each numbers, letters will be treated in terms of a ASCII character, and this ASCII characters will be sent through this D0 to D7. So when this data comes, then the RS value will be equal to 1. Then that will go to your data register and it will get displayed on your LCD display. RW bar is something like a read as well as write information. So usually this RW bar will be grounded because CPU is going to transfer the information to your LCD. So very rarely we try to read the information. The reading, which is nothing but the 7th bit of your command register, the CPU tries to read it. Why it is done? In order to ensure that the earlier sent data, it has been displayed properly or not. So it checks the flag condition. If it is busy, meaning the data has not been printed on the display. So it will wait for some time before sending the next data. So if the busy flag is inactive, then the CPU will understand that the data has been already put onto the LCD display. So it will try to send the next data. Whereas the enable line, it is something like to indicate the data is available on the D0 to D7. So usually this enable line will go from high to low pulse, indicates there is a valid signal on this data line and also on the control lines. So for more information on this pin details as well as the configuration part, please have a look at my earlier video where I have described in detail about the basics of 16x2 LCD. So in this tutorial, I will directly dive into the programming part. Here what we are going to do, we are going to take an Arduino Mega board which contains Mega 2560 microcontroller, and this is connected to a LCD. So as I said earlier, CPU sends the information through D0 to D7. So if it sends the information through D0 to D7, then the LCD is configured in a 8-bit mode. We can also configure the LCD in a 4-bit mode. So instead of sending 8 bits, I can send nibble by nibble. So in this case, we are going to configure our LCD in a 4-bit mode. So we connect the pin number 5 of Arduino to D4 of LCD. Pin number 4 of Arduino is connected to D5 of LCD. Pin number 3 of Arduino is connected to D6 of LCD, and pin number 2 of Arduino is connected to pin number D7 of LCD. And the 3 control lines RS, RW bar and enable. RW bar will be grounded, assuming that the Arduino is going to write the data onto your LCD. So RW bar line will be grounded. So we have 2 control lines connected to your Arduino Mega board. So pin number 12 of Arduino is connected to the RS pin of LCD, and pin number 11 of Arduino is connected to the enable line of LCD. So this is the hardware connection related to your LCD interface with Arduino. So we are going to use Arduino IDE for writing the embedded C program, and we are going to simulate the hardware using Proteus 8 simulator. So first, let us start with Proteus simulator. So first I am going to create a new project. So I go and select the location where I want to put my project. So I am selecting a folder and I am going to give a name for this project as LCD. And the project will have a file extension of .pdsprj. We need to select a schematic to build our circuit. So I am going to create a schematic of default shape. Next, we are not going to do any PCB layout, so I am going to leave it as it is. Next, and I am not going to use any firmware. Next. So here you can see we have selected only the schematic part, no PCB as well as no firmware. Press finish. So it will open this schematic window. So first thing is, in order to create our project, we need to pick the items which we want for our circuit. So I go to pick device. Here I type Arduino. I select Arduino Mega 2560, add it to the list. Then I require an LCD. So type LCD. So in LCD, 16x2 alphanumeric LCD number is LM016L. So I am going to, you can see the pin details of the LCD here. So this is the LCD which we are going to use. This is a 16x2 LCD. So I double click on it, it will get added to your list. So these are the 2 things which I require for this program. So I have selected all the components, I press OK. Now we are going to build the circuit. So I select Arduino Mega, put it onto the schematic. Here I am going to connect my LCD. So LCD I am going to take and I am going to place it in my schematic. So now I have to decide the pins, which pins I am going to connect to the Arduino board. So I am going to use RS. I am going to connect it to pin number 11, pin number 12. I am going to select. You can connect in any GPIO pins. I am going to take RS, connect it to pin number 12, Enable, I'm going to connect it to pin number 11. Then D4, I'm going to connect it to 5, pin number 5. Same way D5, I will connect it to pin number 4. D6, I will connect it to pin number 3. D7, I am going to connect it to D2. So these are the 6 lines which is going to be connected between your Arduino board and a LCD display. So other pins we need to either give a power supply or a ground. So let me select a power. So power, I need to connect it to VDD. Other lines and all, it is grounded. So I am going to select a ground, place it in the circuit, then connect the D0 to D3 to ground. Since we are not going to use it, I am going to connect this 4 lines to ground. RW bar also I am going to connect it to ground because we are going to write the data into your LCD. We are not going to read the busy flag. And the VEE line also I am going to connect it to ground. Okay, which means we will get a high contrast in the LCD display. So now the circuit part is over. So I am going to save this circuit. So this pin details we should remember. So where we have connected our, so and one more thing, our VSS also we should connect it to ground. VSS, it is connected to ground. So we should know the hardware circuit part. So pin number 12 of Arduino is connected to RS, pin number 11 of Arduino is connected to enable, and from D4 it is connected to pin number 5 of Arduino, D5 is connected to pin number 4 of Arduino, D6 is connected to pin number 3 of Arduino, D7 is connected to pin number 2 of Arduino. So this pin configuration we will be using in our Arduino IDE. So let us go for Arduino. So in Arduino IDE, so we have a header file for using the LCD displays. So we have to include that header file to our program. So we use the function #include liquidcrystal.h. This is the header file related to that LCD, so which we can make use in our program. So once you included this header file, we need to define the pins. So as the hardware circuit is concerned, we have connected RS to pin number 12, enable to pin number 11, D4 to pin number 5, D5 to pin number 4, D6 to pin number 3, D7 to pin number 2, RW bar we have grounded. So I call this function liquid crystal, I give a name for our LCD and we define the pins. So RS, enable, D4, D5, D6, D7. The pin details are given in this order. So then we have 2 functions in our Arduino, void setup and void loop. So we already know that this void setup function will run for only once, whereas the loop function will run for infinite number of times. So we can do the initialization part of our LCD in the setup function. So how to initialize it? We use this name LCD, LCD.begin, and I give what type of LCD it is. So since we are using 16x2 LCD, we specify it as 16,2. Then in the loop part, I am going to set the position where we want to put our first character. So LCD set cursor 0, 0. 0, 0 indicates first row, first column. First row, first column address is given, and in that location we are going to start printing the data. LCD.print, the data is Arduino Mega. So that is given in the double quotes. So any string value in embedded C program, it should be represented using double quotes. So we are going to put this data onto your LCD Arduino Mega. So this initial position alone we have set. So in that position A will get displayed, and this dot print function will automatically increment the position, thereby displaying the remaining characters. So once this is done, we are setting the cursor value to 0, 1, which indicates first value is a column value, second value is a row value, which indicates we are going to use the second row first position. Second row first position, we are going to display the programming part. So then, in order to retain this value for some time, we use a delay function of 500. So once this is done, what I am going to do is I want the display to move towards right. So in order for the display to move towards right, I am going to use the function dot scroll display right. Similarly, we have a function called as dot scroll display left, which will make the display to move towards left. So I am going to move the display towards right by 1 position. Again, retain the value to visualize the result. Again, I am going to execute the same function. So again, it will make 1 step towards right, retain the value for half a second, then again move the display towards right. So 3 times the data is going to be shifted towards right. So after doing that, I am going to clear the display. So it gets erased, completely erased. Since this program is in a loop, again the cursor value will be set with 0, 0. Then we are going to print Arduino Mega, and then again in the second line we are going to print programming, then move the display towards right by 3 times. So this process continues again and again. So that is what we have done in our programming part. So once we have done with the program, so let us save this program. So I will create a folder with the file name lcd.c. So our file name should have an extension .c. Save. So once this is done, we need to compile the program, and also we need to convert this program into a hexadecimal file. So in order to do that, go to Sketch, export compiled binary. So this will convert your embedded C program into a hexadecimal file. So now we are ready with the circuit, we are ready with the hexadecimal file. We can import this hexadecimal file onto the simulator. So go to Proteus, right click on this Proteus, edit properties, select the hexadecimal file. So in Arduino, I have lcd.c. In that I am going to select the hexadecimal file. So we have imported the hexadecimal file into the Arduino board. So once this is done, we need to check whether our program is working properly or not. So I am going to execute the logic. So when I execute it, you can see it is getting displayed. In the first row, first line, we have Arduino Mega. In the second row, I have programming, and you can see the display gets shifted towards right by 3 times, then again it goes to the initial position. So our program works as per our requirement. This is how we can interface a 16x2 LCD with a Arduino Mega board. In order to stop the simulation, I go and stop the simulation part. So thanks for watching. Please subscribe for more technical learning. Thank you.